In this video, I'm going to explain the first part of the Olympus Mons Rover challenge. So, to give you the context, on the 18th of February 2021, Perseverance became the latest rover to touch down on Mars. With a range of new technology, Perseverance was dropped onto the Martian surface using the Sky Crane system, which is a very sophisticated multi-stage landing system which was designed to land the rover safely on an uneven terrain, where some of the previous approaches using things like large parachutes and inflated balls just wouldn't work. Landing a rover requires a very sound understanding of motion, flight, and aerodynamics in order to provide a smooth landing for very sensitive equipment on board the rover. On Mars, Olympus Mons is a gigantic volcano. It stands 21.9 kilometers tall, which is 2.5 times taller than Mount Everest. Uncovering soil samples near the top of the volcano can provide highly valuable details towards uncovering the history of this planet. Given Mars's atmosphere is very thin, 1 to 2% that of Earth, very little greenhouse effect takes place. And in winter, because of this, Mars can get extremely cold. Temperatures of negative 153 degrees Celsius have been recorded. Your mission. Your team have been tasked with a new mission. You are to land a specialized rover safely on top of Olympus Mons, which will collect soil samples of the volcanic soil. Given the extreme cold on top of Olympus Mons, the rover will only have a very short time to collect samples, and then must use its potential energy to roll down the mountain face in the fastest possible time to reach a lower, warmer surface before its hardware freezes. The rover must be flown and land safely on the surface in precisely the designated location without any damage, and then optimize the conversion of potential to kinetic energy by rolling down the slope as fast as possible. For this task, there will be 3 key pieces. Part 1 is to design a craft to provide a maximum flight time of the rover. So this is basically a plane design system or a shuttle design system. Part 2 will be designing a rover that optimizes this conversion of potential to kinetic energy in the most efficient way. And Part 3 involves designing a landing system that will drop the rover from a designated location to land on the ground below. In this video, we're going to just look at Part 1 and its considerations. So Part 1 is the flight component. This will be done as a group, and you are to design and build a craft that can fly/glide with a provided payload that simulates the rover. So you will be given an object, which is a box, that simulates the maximum dimensions of the rover that you can build in Part 2, and your craft needs to hold that payload however you want. It can either carry it within the frame, so you can have a compartment in your plane that it's built into, or you can externally mount it, so you can strap it to the bottom of the fuselage or something like that. It's entirely up to you. The craft has to meet the following requirements. It must have a stable flight and the ability to glide a very long distance. It must be capable of carrying the payload, which simulates your rover provided, and it cannot have the payload glued in or permanently fixed to the craft because it needs to be removable. So I would recommend something like a compartment that it sits into. You might build some sort of a locking mechanism to hold onto it, whether that's spring-loaded or elastic bands or something. Come up with a creative way to strap the payload to your plane so that it doesn't move around. And the plane can be any shape you wish, but it cannot exceed the overall dimensions of 600 mils wide by 450 mils long. It can be made out of any material you want, but you will have access to things like 3D printers, laser cutters. We've got a huge surplus of balsa wood, and we've got a surplus of composite fiberglass sheeting. We've got a surplus of aluminium composite sheeting, which is a very thin layer of aluminium sandwiched between a piece of foam. So it's really strong and it's quite lightweight. It's entirely up to you. You will have the opportunity to test your plane once you've designed and built your final prototype, but it'll be tested in 2 forms. It'll be tested on a power anchor, which is a motorized device that'll basically spin an arm around and around in circles, simulating the plane being flown. And it's also going to be launched from a height. So we're going to find a high place in the school, and we're going to throw your plane off the roof and measure the maximum distance that it travels. Your results will be recorded by the end of that testing lesson. You can make any repairs or modifications as you need. So if something breaks, you can patch it in that lesson and retest. If you think of some way to improve it as you go through, you'll have that lesson to do it. You may test a maximum of 4 times. And this is to simulate the real world. In the real world, we don't have an infinite amount of money, and we also don't have an infinite amount of time. Mars is only in a close proximity to us at a very specific time of the year. If you miss this deadline, you've got to wait a whole nother year before that comes back around. So in this case, we're simulating that by saying you can only test it 4 times. We are going to record a score for this criteria. So your flight results will be measuring points, and the first allocation of points is based on the power anchor test. So if it does not fly, you get 0 points. If it's a wobbly and unstable flight, you're going to get 50 points. If there's only a small amount of wobble or instability, that's 300 points. And if it's smooth and stable, that's 600 points. The next point system is the distance from the launching point. So how far it traveled. You get a score for every centimeter. So your answer here is how many centimeters. If it travels 20 meters, that's 2,000 centimeters from the distance that it was thrown. That would be your score. And lastly, the payload condition is what happened to the payload itself. If it's disconnected from the craft or it broke, you get 0 points. If it's loose or unstable, or there's some minor damage to it, 50 points. And if there's no damage and it's still secured on landing, you get 300 points. In the next video, we'll look at part 2, the racing rover, but for now, that is the requirements for part 1. We're going to use the engineering design process throughout this process, so we're going to deal with that a little bit more in tech, but that is part 1 of the Olympus Mons Rover Challenge.